The name NASA is basically everywhere on clothing and in the movies. Some youngsters even dream of becoming astronauts or working for NASA, but have you ever stopped to think about the possible careers at NASA and what they are? Well, if you have, then you are in the right place, as today we will be diving into the possible career choices as well as their possible salaries at NASA. Please keep in mind the salaries we will discuss in the video might not be 100% accurate. I know we have not posted new content in a while, so before I begin I would like to welcome the following subscribers to our mysterious community. Atoshir, Sanlam P. Chase and N. Davison, thank you for subscribing, and welcome to our mysterious community. Now, let's jump in, shall we? We all know that NASA is a massive space agency, but what careers do they offer exactly? NASA offers more possibilities than just becoming an astronaut. They offer jobs in the following fields as well, namely, scientists, engineers, IT specialists, human resources specialists, and they also assist in jump-starting businesses to grow the economy. However, the most common jobs at NASA is offered in the following field: aerospace engineering, general, and computer engineering. So let's take a look at what you need to work at NASA as a scientist or engineer. To work at NASA as a scientist, you will need a minimum of a bachelor's degree in physics, astronomy, geology, space science, or a similar field, as well as a master's degree or PhD. However, this will allow you to start on a higher salary. Let's take a look at 15 NASA career options and their salaries. Avionics technician. Avionic technicians get an average salary of $40,018 per year. That's about $3,335 per month. So what do avionics technicians do? An avionic technician works with the central systems of spacecraft and satellites, such as communication and navigation systems. They may assemble, install, repair, and test components for these systems or replace a malfunctioning component. When applicable, they use flight test data to identify potential performance issues so they can fix components before a malfunction occurs. Avionics technicians also keep detailed documentation of their work, including a record of any repairs and malfunctions, which engineers use to improve designs. Photographer. NASA photographers get paid an average salary of $41,705 per year. That's about $3,475 per month. Photographers at NASA take photos at many stages of a space project to document its progress. They may work closely with engineers and scientists to photograph important moments in the project, such as a discovery, event, or launch. Their documentation may include taking photographs of a project's team members, which can act as a record of NASA activities. Photographs from NASA can have many uses, such as being included in publicity or marketing, posted on social media, or published in scientific papers. Computer engineer. Computer engineers get paid an average salary of $52,121. That's about $4,343 per month. Computer engineers design, test, and develop the computer hardware and other systems NASA uses. This can include the computer systems NASA uses to observe space, such as measuring an activity and collecting data, or the hardware researchers, scientists, and other engineers use. When designing a new product, computer engineers create detailed documentation of their process and instructions for others to use it properly. Other responsibilities can include testing software, creating programs, setting up networks, and troubleshooting glitches or malfunctions. Producer. NASA producers get paid an average salary of $55,658 per year. That's about $4,638 per month. Producers at NASA primarily work on educational videos, which may be for internal use and training, such as a video demonstrating how to assemble, use, and repair certain equipment. NASA may also distribute these videos to the media, schools, or the public to explain scientific concepts. Producers manage many aspects of filming these videos, such as the budget, production schedule, and crew selection, and they may give the director input on creative decisions. Technical writer. Technical writers get paid an average salary of $59,097 per year. That's about $4,924 per month. Technical writers translate complex scientific information into language the public can understand. They work closely with scientists and engineers to learn the details of their projects, missions, and research and identify the details that are most helpful for people to learn. They also may conduct extra research, depending on the subject. Some techniques technical writers use to simplify information include illustrating the text with visual material, like photographs and diagrams. Electronics technician. NASA electronics technicians get paid an average salary of $62,718 per year. That's about $5,227 per month. Electronics technicians follow directions, diagrams, and specifications to repair or improve electronic components in spacecraft and satellites. They inspect and test components for potential performance issues, identify the causes of malfunctions, and perform maintenance work. They may also install new components, do preventative maintenance, adapt components, and perform safety checks. Other responsibilities can include making suggestions for design improvements, assisting engineers with designing new components, determining material needs, reporting potential hazards, and maintaining detailed records. Meteorologist. Meteorologists get paid an average salary of $66,182 per year. That's about $5,515 per month. Meteorologists are atmospheric scientists who prepare weather forecasts based on observations of the weather and climate. The technology they use in their forecasts includes weather balloons, satellites, radar systems, and computer programs that can analyze weather data and create simulated weather predictions. At NASA, meteorologists may be part of forecasting weather for launches, or they may study the atmosphere and climate from space to improve forecasting technology. Meteorologists may also be involved in heliophysics projects that study the activity and behavior of the sun. Public relations specialist. Public relations specialists get paid an average salary of $67,584 per year. That's about $5,632 per month. Public relations specialists at NASA provide information to the media and public about space projects, events, and discoveries. They may release this information through press releases, blog posts, or social media. Their work also involves arranging media interviews for NASA professionals such as scientists, researchers, and astronauts, and teaching them how to communicate effectively to help them prepare for those interviews. Other responsibilities can include responding to media requests, working with schools to arrange educational speakers, writing speeches, and coordinating with others on the publicity team. Aerospace technician. Aerospace technicians get paid an average salary of $71,049 per year. That's about $5,920 per month. Aerospace technicians help engineers design, develop, and test spacecraft and satellites. This often involves preparing equipment for testing, conducting tests, and recording and analyzing results. After comparing the results against the test's objectives, they work with an engineer to identify changes and adjust the design before running more tests. Aerospace technicians also may maintain equipment, monitor inventory, and write reports to assist engineers. Mechanical engineer. Mechanical engineers get paid an average salary of $81,178 per year. That's about $6,764 per month. Mechanical engineers collaborate with other engineers to create parts for their products. Components they might design include engines, sensors, and steering mechanisms that go into rockets or satellites. They also may examine and repair the components they create or train others on the maintenance of the components, such as writing a detailed document explaining how it works. Other responsibilities can include developing prototypes, overseeing the manufacturing process, testing components, analyzing malfunctions, identifying solutions, and adjusting designs. Aerospace engineer. Aerospace engineers get paid an average salary of $103,655 per year. That's about $8,637 per month. Aerospace engineers at NASA design and create spacecraft and satellites. They research current and new technology, work with a team to create the design, and oversee the manufacturing process. They also perform extensive testing, which can involve using environments that simulate outer space, so they can ensure the product works without resources like oxygen. After testing, aerospace engineers identify the source of a malfunction and determine adjustments that may improve performance to troubleshoot issues. Propulsion engineer. Propulsion engineers get paid an average salary of $106,298 per year. That's about $8,858 per month. Propulsion engineers are aerospace professionals who design the propulsion components for aerospace devices, such as spacecraft and satellites for NASA. These components can include engines, control systems, propellant systems, compressors, pumps, and fuel systems. Propulsion engineers may design assessment tools for testing their designs, and their work often includes creating blueprints for new designs, improving designs, making prototypes, testing components, and helping with manufacturing. Other responsibilities include collaborating with other engineers, performing tests to ensure safety and performance, working within a budget, and creating instructional and repair documents. Electronics engineer. Electronics engineers get paid an average salary of $108,550 per year. That's about $9,045 per month. Electronics engineers design and test the electrical equipment and components in spacecraft and satellites. Their work usually focuses on smaller, specific components such as instrument panels, radar systems, or communication systems in spacecraft. They ensure the components are high quality, function properly, meet the necessary standards and regulations, and are safe for astronauts or other aerospace professionals to use. Engineers also often document their work and create detailed maintenance procedures for their designs to help with future repairs. Avionics engineer. Avionics engineers get paid an average salary of $120,923 per year. That's about $10,076 per month. Avionics engineers design, develop and test the avionics systems for spacecraft and satellites, which include the systems for communication, navigation, and weather radar. They work with a team of engineers and technicians to create project proposals they can complete within budget, and they design criteria to measure the performance, safety, and quality of the final product. They perform rigorous tests on the systems and troubleshoot any malfunctions. Other responsibilities can include mentoring junior engineers, consulting on other projects, and documenting their work. Astronomer. Astronomers get paid an average salary of $128,950 per year. That's about $10,746 per month. Astronomers are scientists who study the universe and the celestial bodies within it, including stars and planets. They collect data about celestial bodies using equipment like telescopes, satellites, and space probes, and they use the data to better understand the age and composition of the body. Astronomers also may design and test new scientific instruments to help them collect data. At NASA, an astronomer's data and discoveries can guide missions by finding potential areas of the universe to research. Please take note that the salary discussed is an average salary. It can be more based on your qualifications and experience. So how hard can it be to land a dream job at NASA? According to the research I have done, it is not actually that hard. If you have the necessary qualifications and experience, when you apply for an open vacancy, you can easily land your dream job. Ever wondered, where will you work? Well, NASA can station you in a few different locations depending on your career field. They can station you at NASA Headquarters, Washington, District of Columbia. NASA Headquarters, located a few blocks from the U.S. Capitol, is the center of leadership for the agency's activities. Under the guidance of the administrator, NASA HQ provides overall guidance and direction to the agency. Ames Research Center, Moffett Field, California. NASA's Ames Research Center is located in the heart of California's Silicon Valley. Ames partners with a variety of leading educational institutions, non-traditional international partners, and high-tech companies in Silicon Valley. These partnerships stimulate and enable new intellectual talent, ideas, and technologies to sustain and advance NASA's missions. Ames provides NASA with advancements in these areas: hardware and critical life science research payloads for the International Space Station, critical heat shield development for Orion as well as for commercial vehicles, management of IRIS, a heliophysics mission that will help us understand Earth's relationship to the Sun, management of the LADEE mission, which provides an understanding of lunar dust dynamics, management of the Kepler mission, which is searching for exoplanets. Armstrong Flight Research Center, Edwards, California. Formerly known as Dryden Flight Research Center, Armstrong is the agency's primary center for atmospheric flight research and operations. Located in the western Mojave Desert, Armstrong is situated to take advantage of the exceptional year-round flying weather, remote area, and excellent visibility to test some of the nation's most exciting aircraft. Armstrong assists NASA in reaching its goals through the following efforts. Supporting the Space Launch System control law development by using test assets to simulate portions of the launch trajectory. Supporting International Space Station operations by providing a communication link and the ability for tracking radars. Operating aircraft platforms and supporting technology development and research. Performing flight tests that yield critical research data for advanced supersonic aircraft. Glenn Research Center at Lewis Field, Cleveland, Ohio. Glenn excels in the research and development of innovative technologies for both aeronautics and spaceflight. A multitude of NASA missions has included elements from Glenn, from the Mercury and Gemini projects to the Space Shuttle program and the International Space Station. Glenn supports all the agency's missions and major programs, including these efforts. The Human Research Program by developing medical devices and exercise equipment that mitigate health risks for explorers. Commercial partnerships by allowing the use of wind tunnels, space simulation chambers, and large-scale environmental simulation test facilities to commercial partners. Development of advanced in-space propulsion and power capabilities to enable travel to destinations outside the reach of chemical propulsion systems. Development of propulsion technologies with the specific objectives of monitoring and reducing factors that have a negative impact on the environment. Goddard Space Flight Center, Greenbelt, Maryland. Goddard is home to the nation's largest combined organization of scientists, engineers, and technologists. They build spacecraft, instruments, and new technology to study Earth, the Sun, our solar system, and the universe. The center is a major UOS laboratory for developing and operating unmanned scientific spacecraft. Goddard manages many of NASA's Earth observation, astronomy, and space physics missions. Goddard supports NASA through these activities, working with other NASA centers, academia, and industry to conceptualize, design, build, test, integrate, and operate space, airborne, and ground-based missions, spacecraft, and state-of-the-art instruments. Using research from the Space Weather Program to further NASA's understanding of the Sun's effects on Earth and advancing scientific knowledge of the solar system as it relates to life and living on our planet. Designing, fabricating, testing, and operating remote sensing satellites and airborne and ground-based instruments. Observational data from all three vantage points are analyzed to provide a comprehensive picture of the current state of our environment. Developing and operating the space and ground network systems that enable communication for NASA's scientific exploration missions, both human and robotic. Jet Propulsion Laboratory, Pasadena, California. The Jet Propulsion Laboratory leads NASA's robotic exploration of space beyond Earth orbit. JPL's missions to all planets in the solar system provide the foundation of our understanding of the origin, evolution, and destiny of Earth itself. JPL contributes scientific investigations and enabling technologies for NASA's programs in astrophysics, Earth and planetary science, and heliophysics through the following capabilities. Expertise in deep space robotics that has enabled more than a decade of the continuous presence of rovers on Mars. Expertise in low-thrust propulsion, guidance, navigation, and proximity operations employed by missions to asteroids and small bodies in the solar system. Management of the Mars and exoplanet exploration programs for the agency. Management of the Deep Space Communications Network that enables NASA's deep space mission telecommunications and navigation. Johnson Space Center, Houston, Texas. Johnson is a hub of NASA human spaceflight activity. As the home to the U.S. Astronaut Corps, the International Space Station program and mission operations, and a number of space development projects, Johnson plays a pivotal role in the use of the International Space Station as a cornerstone of human exploration that enables the emerging human spaceflight industry and extends human exploration beyond low Earth orbit. Besides their role in the leadership of astronaut training and space station mission operations, Johnson fills these roles. Leads in the development of the Orion Multipurpose Crew Vehicle, several advanced exploration systems projects, the Human Research Program, and various technology efforts. curates all NASA extraterrestrial materials. Kennedy Space Center, Florida. Kennedy is home to NASA's Launch Services Program. This program is responsible for launching satellites and robotic missions. Kennedy Space Center is transforming into a multi-user spaceport to support both government and commercial customers. Kennedy supports NASA through the following efforts. Managing the Commercial Crew Program. The program facilitates the development of U.S. commercial crew space transportation to and from low Earth orbit and the International Space Station. Developing ground systems and plans for Orion and Space Launch System assembly and integrated tests for the Orion test flight, the SLS missions, and other future missions. Optimizing NASA technology investments by leading in-situ resource utilization, or ISRU, technology development for multiple destinations. Langley Research Center, Hampton, Virginia. Langley forges new frontiers in aviation and space research for aerospace, atmospheric sciences, and technology commercialization to improve the way the world lives. Langley supports the agency by providing the following: leadership of the Orion launch abort system and development of heat shield and landing systems that include conducting key water impact tests. Support for deep space exploration through advanced exploration systems projects. For the AES projects, Langley supports radiation protection, advanced sensor systems for automated hazard detection and avoidance during entry, descent, and landing, autonomous rendezvous and docking, and advanced composite structures. Support the Human Research Program by developing radiation transport and design codes and establishing computational frameworks to enable future biological countermeasure development. Applications of breakthroughs in lightweight materials and structures, nanotechnology, and hypersonic aerodynamic inflatable decelerators. Marshall Space Flight Center, Huntsville, Alabama. Throughout its history, Marshall Space Flight Center has served as the space transportation design, development, and manufacturing leader for NASA. Today, Marshall serves the agency by performing the following tasks. Provides expertise with large-scale, complex systems to develop the Space Launch System or SLS. Serves as the 24/7 command post for International Space Station science and sustains the space station life support systems. Uses test facilities to simulate space and ensure the success of the James Webb Space Telescope and other observatories. Uses the Chandra Observatory and other instruments to study the universe and to expand our understanding of heliophysics. Manages the server program that uses NASA satellite data to help developing countries manage resources. Manages the ISERV camera on the International Space Station. The camera captures images beneficial for disaster relief. John C. Stennis Space Center, Mississippi. For more than 4 decades, the Stennis Space Center in southern Mississippi has served as NASA's primary rocket propulsion testing ground. Today, Stennis supports the agency through the following efforts. Providing and managing the resources, facilities, and expertise to provide NASA and the aerospace industry with propulsion test capabilities. Supporting the Space Launch System, Launch Services Program, Commercial Resupply Service, and Commercial Crew Program. Goddard Institute for Space Studies, New York City, New York. Space-based observations provide a critical perspective for monitoring global climate and developing an understanding of Earth systems. Climatologists at the Goddard Institute for Space Studies work with this data. Current research at the Institute emphasizes a broad study of global change and addresses natural and man-made changes in our environment that affect the habitability of our planet. Independent Verification and Validation Facility, Fairmont, West Virginia. A software error, whether it originates in a spacecraft or at control centers on the ground, has as much potential to bring a mission to a halt as a hardware problem. That's why the Independent Verification and Validation Facility puts critical mission programs through elaborate testing. The primary function of the IVANV is to ensure that specialized computer programs, developed for missions, operate perfectly. Michoud Assembly Facility, New Orleans, Louisiana. NASA's Michoud Assembly Facility is a world-class manufacturing facility providing vital support to NASA exploration and discovery missions. Michoud supports several major projects for America's next generation of space transportation vehicles, including NASA's Space Launch System Heavy Lift Rocket, managed by Marshall, and the Orion spacecraft, managed by Johnson. NASA Shared Services Center, Mississippi. On the grounds of Stennis Space Center in Mississippi, the NASA Shared Services Center performs selected business activities for all NASA centers in financial management, human resources, information technology, procurement, and business support services. The NASA Shared Services Center performs a variety of transactional and administrative activities. Consolidation allows the center to increase operational efficiency and improve overall customer service. Plum Brook Station, Sandusky, Ohio. Work at NASA's Plum Brook Station is performed at one of 4 facilities. The Space Power Facility is the world's largest space environment simulation chamber. The Spacecraft Propulsion Facility tests rocket engines and engine upper stages by simulating high-altitude flight. The Cryogenic Propellant Tank Facility is used for large-scale experiments using cryogenic liquid hydrogen. Finally, the Hypersonic Tunnel Facility is a wind tunnel that can test propulsion systems in conditions simulating flight at speeds exceeding Mach 5. Wallops Flight Facility, Wallops Island, Virginia. NASA's Wallops Flight Facility is NASA's principal location for the management and implementation of suborbital research programs. The research and responsibilities of Wallops are centered on the philosophy of providing a fast, low-cost, highly flexible, and safe response to meet the needs of the United States aerospace technology interests and science research. White Sands Test Facility, Las Cruces, New Mexico. For all the data that satellites gather to be of any use, it has to be sent back to Earth. Antenna dishes at NASA's White Sands Test Facility, near the foot of the San Andres Mountains, are just part of NASA's ground-based ways of talking to orbiting spacecraft and collecting their data. The White Sands facility conducts simulated mission duty cycle testing to develop numerous full-scale propulsion systems. Well, that was a mouthful. We have looked at everything on NASA careers. If you enjoyed the video and you think we deserve it, please subscribe to our channel as we do a lot of interesting videos. If you have a topic you would like to see us cover, please drop them in the comments below. Take note, there are many more jobs than the ones we listed in our video today. I left the link to the website if you are interested. That's it from me, until next time.